Okay, so now that we have anatomical terms, let's use some color coding to do uh, some pathways. But let's remind ourselves here and let's use some color coding. That is somatic sensory. So a neuron that would be carrying information from like your liver might end there. The other one that we have here is visceral sensory. We've got the visceral motor, and then here, this is where synapses of somatic motor neurons happen. And you're kind of like, all right, I get the designations, but how does this work? What does this mean? All right, so let's draw a picture of your liver. Here's your liver. It kind of has two lobes to it. And there are many chemoreceptors in your liver that monitor your pH. In fact, let's draw a neuron that is in your liver monitoring pH, right? And this is a sensory neuron. So what it's going to do is it's going to carry information in the dorsal ramus through the spinal nerve, into the dorsal root through the dorsal root ganglion, and then it's going to enter into the spinal column and it's going to end right there because it is a visceral sensory neuron and it's also unipolar. So it ends in the visceral sensory place. There is another neuron that picks up the action potential, and that neuron has a specific name to it. Those neurons are called interneurons. Let me write that in white here. Oh, no, let me write that in black. We have not yet really talked about interneurons. They're basically neurons that are specifically in the central nervous system, and they make decisions. So this interneuron says, thank you for the sensory information. I know exactly what to do to that. And what it does is it travels to this visceral motor area. And lying in wait in the visceral motor area is a neuron that it synapses, and that neuron carries information out the ventral root through the spinal nerve, out the ventral ramus, and that may actually carry information back to the liver. Maybe it carries information back to the gallbladder, but no matter what, it's going to hook up with smooth muscle because it's involuntary, that's visceral. It could hook up with some glands. It could possibly hook up with some cardiac muscle. So this motor neuron could innervate any of these structures, activating them. And this, what you have here is a circuit. You have a sensory neuron bringing information in. You have an interneuron making a decision. And then you have a motor neuron bringing information out. All right, let's do another one. Hold on. I forgot to make more and more slides. All right, let's do another one. Let's do, I got a good one. Let's do a very terrible picture of the leg. And if you've ever had the muscle spindle in your leg activated, it's when they tap on the top of your knee. And so there's this spindle that's here in your knee that has this like wrapping around it. And we would call that a mechanoreceptor because it feels vibrations, pressure, touch from the outside. And so we tap on that mechanoreceptor and it activates, and information travels down a neuron through the ventral ramus, through the spinal nerve, through the, dorsal ramus, through the spinal nerve, through the dorsal root ganglion. And because this is somatic sensory, this neuron ends right here. The interneuron picks up the information, says, oh, thank you for telling me that someone tapped upon that muscle spindle. And what it does is it brings the information to a motor neuron that is leaving the spinal cord. So it synapses with a motor neuron that leaves through the ventral root, through the spinal nerve, through the ventral ramus. And what this does is this might innervate some muscles on the leg, right? So I can tell you right now that it does innervate the rectus femoris, and it causes it to contract. At the same time, it also innervates the biceps femoris, and it makes the biceps not contract. So this neuron can carry both activating and inhibiting information. Let's do another one, because repetition is what really drives information home sometimes. Let's activate more neurons. Let's pretend that we have your skin here. So here's your skin, here's the epidermis, and you've got a hair in the skin. And I don't know if you remember, but the root of a hair is innervated with sensory neurons. And they're free nerve endings, so they don't have like a specific thing like a laminated corpuscle or a muscle spindle. They're free nerve endings. And what this nerve does is it maybe gets activated by a mosquito. Right? It touches the hair, and the hair is like, hello, sensory information. And so an action potential travels along the sensory neuron through the dorsal ramus, through the spinal nerve, through the dorsal root ganglion. And because this is in your skin, it stops here at the somatic sensory area in gray matter where the synapse occurs. An interneuron picks up the information, and the interneuron says, thank you, thank you. I'm going to go and synapse with a neuron that's in the somatic motor area of the spinal cord. And it says, please carry this information out. So that motor neuron leaves through the ventral root, through the spinal nerve, through the ventral ramus. And this might innervate the muscles of the hand, like the palmaris longus, so that you can slap the mosquito. So, oh, I'm sorry, I don't want to draw an arrow there. I would like to draw a neuromuscular junction innervating the muscles of the hand. And I know that's the neuromuscular junction because this is skeletal muscle. Right? When I had a neuron coming from the visceral motor area, that innervated cardiac muscle or smooth. If I have a motor neuron coming from the somatic motor area, it always innervates skeletal muscle. All right, we're not done. We're not done. I got two more. I mean, you can stop watching if you want. That's all you. But I got two more of them. All right, so let's do the skin again. This is skin. This is the dermis down here. And we know that you have free nerve endings in the dermis. And some of these are capable of detecting temperature. And what they do is they say, oh my gosh, it's gotten very cold outside. And it sends that information through the dorsal ramus, through the spinal nerve, through the dorsal root ganglion. And because this is skin, this neuron ends right here in the somatic sensory area. An interneuron picks up the information and says, oh, all right, I'm going to send that to a neuron that's going to leave the spinal cord. And I'm going to send that to a neuron that's right here in the visceral motor area. Because, and work with me here, this neuron's going to carry information out through the ventral root, spinal nerve, ventral ramus, and this is going to innervate blood vessels, which are visceral. And so the blood vessels are now going to constrict in response to the cold temperature, right? If this were hot temperature, it would innervate blood vessels and at the same time sweat glands, but it would still be a somatic sensory because it's in skin and a visceral motor neuron because it's going to innervate things that you can't consciously control. All right, last one. Oh, I love this one because I get to draw your colon. So this is your sigmoid colon right here, that which kind of curves around. This is your rectum, and right here is the anus. Actually, you have smooth muscle and skeletal muscle around the anus. So this is your colon, or your large intestine. This is the rectum. And as we realize, there is smooth muscle that you cannot control. But outside of that, there is a ring of skeletal muscle that you can control. If you don't control it responsibly, the control over it will be revoked. So there are some baroreceptors innervating your rectum. And what it's doing, receptors, what it's doing is that these baroreceptors are monitoring the pressure in your rectum. And as feces build up, the baroreceptors say, oh, hey, information. And they send an action potential through the dorsal ramus, through the spinal nerve, through the dorsal root, through the dorsal root ganglion. And because this is visceral, it ends right here in the visceral sensory area. All right, let's make this complicated. So, this information actually synapses with three things. This information synapses with your skeletal muscle. It also synapses with your smooth muscle. So this information connects to motor neurons that control both sphincters. And that's what these are right here. They're rings of muscle called sphincters. At the same time, we are also synapsing with a neuron that travels up to the brain and says, hey, you have to poop. So let's draw the two neurons here as they work. So there's one neuron controlling the skeletal muscle sphincter, which is called the external anal sphincter. And that is waiting for your signal from your brain. There's another neuron here that starts here, travels out the ventral ramus, spinal nerve, ventral root, spinal nerve, ventral ramus, and this goes to the internal anal sphincter, which is smooth muscle. In fact, we can abbreviate those up here. The smooth muscle up here is the internal anal sphincter, and the skeletal muscle is the external anal sphincter, right? So IAP, EAP. So it doesn't have to be so simple that one neuron goes in and one neuron goes out. In fact, there will be another neuron descending from the brain, synapsing over here to control that external anal sphincter. So it's not as simple as you would think. It's not just in and out, but you have to consider that some information is going to be traveling to the brain and some information is going to be coming from the brain. But depending on that type of information, we still synapse in these gray matter areas. So we can say in the anterior horn, we synapse sensory information. In the posterior horn, we synapse sensory information. In the anterior horn, we synapse somatic motor information, right? So knowing these gray matter areas, what they do, somatic sensory synapse, visceral sensory synapse, but also knowing the anatomy in which they lie. So if you want to use these terms, you should also refer to those gray matter horns, right? So if you say the neuron synapses in the visceral sensory area of the spinal cord, get more specific. The neuron synapses in the anterior horn of gray matter of the spinal cord, where synapses for somatic sensory information is performed.